Everyone. In this video, we're going to take a look at a genetic algorithm which is going to teach a population of snakes how to play the snakes. Every 100 generation will save the best snake and see how it actually performs. You can follow the progress of it in the terminal. You can see the average fitness is improving. The snake already learned how to go towards the apple in the first best snake saving that we did in the 100th generation. And this video is going to be a little bit different. Instead of actually in detail reviewing the code, I will have full live coding uh, towards the right after we do the demo. And this is a sample of what you can expect from my 1000x masterclass. The code file, along with the video that you will see, is available at my 1000x masterclass. Here it is, along with 15 other projects. If you like the video that you see today, you can actually, if you become a patron, you'll have access to the code files along with 15 other projects, live coding walkthroughs with Cursor. So let's see how is our snake doing. We missed the second and third generation, but we'll be able to see how the fourth one does. But looking at the terminal, the average fitness have improved considerably. It's a bit of a hit or miss. You can actually go um, backwards in time. Here we're going to see the fourth generation best snake eating going for the fourth apple, fifth apple. So as you can see, it learned quite a lot. Actually, it's doing very well. Let's see how long it can go. So only in 400 generations, we have built a snake that already has eaten 15 apples. So if we were to run this longer, it should get better. But the process is, the best snake actually runs only for 5,000 steps. So I'm going to stop this. As you can see, we can see the best score improving in the next video. The script has all our hyperparameters, and we have a snake class which defines the move and move methods for the snake. And we are using a very simple neural network whose parameters you can adjust from here. You can see the hidden layer size, input size, which represents the snake's so-called vision or the game state size. And the output is, of course, just the actions you can take in a game. Training game speed is how fast we're training. Display game speed is the actual game when the best snake plays, and so on and so forth. So the rest of this video is going to be how I built this and in Cursor. I hope you'll enjoy it. If you are enjoying my videos, take a look at my website, echohive.live, where you can find all my videos with a search functionality. And if you're a patron, you can click on these links and actually be able to download source code for them. But remember, the source code for this will be available at my 1000x masterclass, along with 15 other projects with their videos as well on how I built them. So without further ado, the rest of this is going to be how I built this. Hey everyone, in this 1000x masterclass course, we're going to build genetic algorithm-based AIs learning how to play snake game. We're going to use prominently the Control K or Command K command with Cloud 3.5 Sonnet. So let's begin. Okay, let's go ahead and let's start with this. We want to build a snake pie game in which a population of AIs are learning to play this game using genetic algorithm. Let's see how it codes it. Here it's going to code a neural network from scratch using NumPy. And we are going to have crossover, mutation, and evolution. Let's see how this works. Okay, when we run this, we do get, currently just acting randomly. And I don't see any iterations for different generations. But as you can see, I have actually typed in this prompt, but I haven't accepted the code yet, but this code is runnable. It's actually active. So I can now ask follow-up questions. Okay, actually, I had to start over again with the exact same prompt because I wanted to copy the prompts we use into instructions.txt just in case we start over again. But when I run it now, we get this list index out of range error. So I'm just going to insert this into the follow-up instructions. And when we do that, it keeps track of all the instructions plus the code. So it's like an iterative approach. Let's see what happens now. It is now using, instead of tuples or lists, it's using this pygame.math. You can actually select all this if you wanted to find out about it. Do Control L, bring it into chat, and ask what is vector2 doing here. And we can actually learn more about the process. And if you're interested in genetic algorithms, you can actually read up on it. Really interesting optimization algorithm. Apparently, vector2 is a class from Py, represents a 2D vector used to handle position and directions. Okay, we have our new code. Let's run it. We are actually getting the same error when this happens. Actually, I like to start from scratch. So let's just close this, undo all of this, or actually just delete it. And then let's write some new instructions to it as well. Because, when if you paid attention, we're going to have some population size and some other hyperparameters. So I'm going to ask it to actually create those parameters so we can easily customize them. Okay, I'm just going to say, please make the hyperparameters such as population size available as variables at the top of the script so we can adjust them. So let's go ahead and do this again. There we go, just enter. Okay, this time around we are again using typing, but we have our hyperparameters such as population size, mutation rate, and all that, which we can modify once we get this running again. Okay, currently nothing is happening. Check my CPUs. Okay, there was an issue there. So it doesn't seem to like this prompt. As a matter of fact, let's modify the first instruction. Okay, let's try this. Build a snake game in Pygame in which AIs are learning to play the game using a genetic algorithm. The rest will be the same. Here again, we're going to do Control K. Okay, we're getting another error. Also, it implemented a snake vision function, which it didn't implement. So let's pass this error and also ask, please implement all functions fully. And I'll run it again. It is actually using a tournament style approach to detect the parents. Interesting. But I have looked over the code and it's not using a neural network this time. Let's run it. Again, we're getting this dimension error. I think this is a little bit different. Let's give it and let's allow it to rewrite. Okay, this time I ran it and this seems to be working, but we are not really, like there's only one snake, no instructions. Let's first write it here. Okay, let's ask, we want to see all snakes play the game at the same time and see how they evolve. Also print relevant statistics in terminal. So we're just going to come up and add this as a follow-up instruction. We again, when I tried to run it, got some shape errors with NumPy arrays. Let's give that error message back. And as you can see, these are all the follow-up instructions we have entered so far. Okay, this time around, we got a bunch of different colored snakes playing the game, but we are not, okay, the generations take quite a while to complete. So let's actually close this. We can speed this up by increasing the snake speed. It's currently set at 115. Let's do 150. Now it's much faster and we can see the generations. So we start with, each generation starts with 50. Then we try to select the best generation and move on to the other. But I don't know what kind of fitness function it is actually to select everything and do Control L and ask what kind of fitness function are we using, and is this a good approach? I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. Okay, we are just looking at the snake score for the fitness function it explained. So this is just to show you, that you can learn more about the code that we are writing. I'm going to close this and ask you, please use a neural network approach for learning. So I believe when we do this, let me select this and add it to our instructions. So we can try to run this from scratch as a single go. Okay, this is good. Now we are creating a neural network for each one of the snakes. Hopefully we'll get better performance. And this is a neural network from scratch. It's using NumPy, and it is going to run on our CPU. Okay, this is running, but as you can see, it's still showing at a time. So let's add this. Please show all snakes playing at the same time. We, I suppose, don't have to add this back into instructions because we already had it, but maybe it's forgotten about it. But it is creating the neural network, so that's good. Okay, seems to be working better. We can see the average fitness, it actually increased and now it decreased again. So we want this faster, and it removed the snake speed parameter from the top. Let's add this ourselves just to show you that you can actually modify. Let's do actually 480. You can modify this code without accepting it, and it'll actually make the changes. And the snake speed is right there, clock.tick. We have to pass in game speed, and now if we run it, like much faster, and we can see that fitness is slowly improving. I don't know if you can see, but there is some high numbers showing up. So as the generations advance, this should hopefully take more and more than 11. So average fitness 7 at the end across 100 generations. Can of course increase that too. Can do 1,000 generations, for example. But before we do that, let's add another instruction. Let's ask something like that. Make the Pygame screen large enough so that we can display the relevant detailed statistics to the right of the game screen. Let me copy that and add that as a follow-up. See, as you can see, it kept the game speed. It did reduce it, but we'll increase that to 480. Or actually, let's go. Once it's done, we'll be able to change it. It doesn't let you change it while it's writing the code, but once this turns to blue, then we should be able to. As you can see, it's writing quite a lot of code, 250 lines. Let's come back up here and increase this to even 960. Let's run this to see. Yep, there we go. The game being played, but maybe 1,000. Let's move the generations to 1,000, 100, so we can see the progression. So I've been running it for 1,000 generations and really see that great of an improvement. So let's ask you another instruction here. So I'm going to ask if you ran this for 1,000 generations and didn't see a distinct improvement. Please improve the algorithm so the snakes can learn better and faster. Now, we could have also actually selected the entire, maybe I should have done that, entire code and actually asked in chat so we can get more detailed explanation. Maybe we'll do that again after this is done. Because it would have been nice to actually see what improvements it was going to do over the ones that we already have. That's why for those types of questions, perhaps the chat is a better place and you can always apply the answers that you're getting. Again, I'm getting an error, so I'm going to paste this in. I believe what it did is it increased the neural network size because, yeah, it's increased the input size. So it increased the amount of information that each snake can gather, and it increased the hidden layer size for the neural network. And I ran it, came up with the same error again. Now I'm going to try this one more time since we already been working on it. Okay, now we are going somewhere again, except the game is being played. So let's go back and increase the game speed, 960. It's difficult to tell from here, but if you look at the terminal display, we see that we are now seeing actually more of an improvement. So I've been running this for 500 generations. The average fitness is improving, but I don't think the best score is actually properly calculated because it's always 3, but I can see that average fitness is. And from here, you can see that the game screen is a bit busier, so that means maybe the snakes are taking longer. I guess we need a way to see the best snake playing the game on some regular speed. Yeah, and the performance kind of goes down. This could be due to the mutation rate being too high, possibly. Should lower mutation rate. But before going forward, let's say okay, I'm going to ask something like to save the best snake's weights to a file and play the game with the best snake at regular speed for 500 steps every 100 generations. Have a game speed variable for this as well and continue training. So let's copy this and let's add it as a follow-up instruction. And now we have new variables: training game speed, display interval every 100 generation, and for how many steps we want to display. Best snake play in the game every 100 generation. As you can see, our code is growing quite a lot. We're already at 300 lines, and we'll reduce the mutation rate as well. I think that is what's causing possibly the collapse. Let's go with 0.05 actually. And let's run this. Hopefully we won't have an error. Oh, here we go. Let's see what'll happen. We're almost at 100. Here is the best snake. Oh, it just directly went to the wall, but we'll continue. We look at the fitness scores from the start of the game. It was very low, and now we are getting some really high numbers. We are about to play the 200th generation snake. Okay, it's doing much better, so it's learning. That's good. Also, the best score seems to be now working better. I believe reducing the mutation rate was the key. Here is the third best snake. Let's see how it does. It is only going to play for 500 steps, so actually, this is a limiting factor because 500 steps is not a full snake game, but we do have a best score 6. Maybe that's also a limiting factor right now. So this looks pretty good. Let's go ahead and accept this actually. And while this is ongoing, maybe we can create a markdown file. And as you can see, it's saving the best snakes every 100 iterations. So you can actually continue playing the game from those places, from those break checkpoints. We are going to see the 4th generation snake play the game. Wants to go there. It's getting better, but for sure it's doing so much better. This is not crashing. Here we go. Oh, it's nice. Okay, it finally crashed, or we actually reached the 500 steps. So let's create a readme.md file here. And let's do Control K and do an add, and then click on File and refer to our snake.py. Please explain this code, how this code, code works, along with how the genetic algorithm works in simple, clear English, let's say. They should now to create that markdown file. So now we are actually going to get an explanation. So you can actually read more about it. As you can see, we create an initial population with a random neural network fitness evaluation. Let each snake play the game and calculate its fitness based on score and survival time. Choose the best performing neural network as parents for the next generation. Then we do crossover, combine the weights of parent networks, best ones to create offspring networks. Mutation randomly alter some weights. New generation replaced old population with new offsprings and repeat. Perhaps some of the old population can remain too. So this is quite flexible. But look at this. We reached to 10 best score. There we go. It's the 7th generation best snake. Now, crashed onto itself. We can see from the fitness that actually kind of dropped off a little bit. It's maybe due to creating an entirely new generation, replacing the old population. It's quite a lot to try, but we're now getting close to the 8th generation. There we go. This is the 8th generation snake. Maybe its vision is limited. The input factors for the snake plays a role here too. Yeah, it seems to miss the apple if it's too far from it, but seems to be doing all right. So we'll accept this. You can always generate a more detailed example, but here, if you get game state, see this is the game state. Yeah. So I guess it is getting which direction the food is. So you can modify the game state to give more information for your snakes. Here is the ninth generation, and we have one more generation left. Oh, it didn't miss it. Okay, let's just play the 10th generation as well, and we'll call this video complete. I hope you learned something. The files, of course, is available along with the video. Here is the 10th generation snake. It got its first apple. It's kind of wandering off. Here we go. Oh, collapsed on itself, or we hit the 500. So you can display steps. Okay, actually, while we are training, we are playing until all snakes have failed. But when we are actually playing the best snake, then we are only letting it play for display steps. So we can actually increase this display steps to maybe like 5,000 to see how the snake is really doing. I hope you found this useful. And if you're a connoisseur level patron, remember that I have every week AMA and live coding meetings with my architect level patrons. And if you'd like to join them, feel free to upgrade and hope to see you all. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.